For our final example, we're going to look at what's a double angle of elevation problem. So let's just kind of see what it's saying and then we'll draw it. Francisco needs to know the height of a tree. He needs to know it. He knows that from a given point on the ground, he finds that the angle of elevation to the top of the tree is 36.7 degrees. So let's draw that out. From some point on the ground to the top of a tree, our angle of elevation is 36.7 degrees. So here's what we know so far. Okay. Then he moves back 50 feet, and that only has one significant digit, but let's put a decimal after it just to give it 2 for the rest of this problem. He moves back 50 feet, so this amount is 50, and the new angle of elevation is 22.2, because that's what would happen if he moved back. He wouldn't have to tilt his head up as much to see the top of that tree. So we'll have a lesser angle of elevation. And that's all he knows. He wants to find the height of that tree to the nearest foot. So let's see. This is a right triangle, and we can see that it forms a triangle inside of a triangle. Let's look at just the inner triangle and try to figure out what we're looking for here. If I'm looking for the height of this tree, that's this side. If I look at this inner triangle, the only equation I can write from it is that tangent of 36.7 equals h over x. And I can write that down and that can become my equation. The problem is that that has 2 variables in it. So I don't have enough information from that one triangle to solve this. But if I look at the outer triangle, if I look at it as one big triangle, I can write a second tangent equation. And I can see that the tangent of 22.2 degrees has to equal h over this entire side. Well, that entire side is the original x distance plus the 50 that he stepped back. So that's going to be x plus 50. So now we have a second equation that also has the same 2 variables as the first. So we have a system of 2 equations with 2 unknowns. And we just have to figure out how to go from there to find the value of h. If I look at the top equation, it's really easy to solve that for h. So that's what I'm going to do. I am going to take the top equation, I'm going to stack it over 1 and make a proportion, and see that h equals x times the tangent of 36.7 degrees. I'm going to put a bubble around that, just like we do with any system of equations substitution problem, because really we're just working like this, like a substitution problem. Then I'm going to take that bubble and substitute into the second equation, so that instead of tangent of 22.2 equaling h over x plus 50, it now equals x times the tangent of 36.7 degrees divided by x plus 50. So I just made a substitution there. I substituted this into the second equation. That now is a single variable equation, and I can set it like a proportion and I can solve from here. So now I will stack that over 1 and cross multiply, and I get that 1 times x tangent of 36.7 must equal tangent of 22.2 times x plus 50. But we have to be really careful there because we have to distribute onto that binomial. So really that equals x times the tangent of 22.2 degrees plus 50 times the tangent of 22.2 degrees. And then I just have to figure out algebraically how to solve from there. The first thing I'm going to do is subtract this x tangent of 22.2 from both sides, and that will give me x tangent of 36.7 minus x tangent of 22.2 has to equal 50 times the tangent of 22.2 degrees. so our variables are all on one side, but now we have to figure out a way to isolate that x. And the problem here is that the tangent of 36.7 is one number, and the tangent of 22.2 is another number, but I don't have them written as actual numbers, and there's no easy way to combine them. You can't just subtract the angles. So the trick is you have to factor the x out, but leave the tangents inside the parentheses. We used this when we were solving literal equations back in the early parts of college algebra. Also when we solved logarithmic equations. So we'll factor the x out, and we'll have tangent of 36.7 minus the tangent of 22.2 equals 50 times the tangent of 22.2. And notice, this right here does not become 15.5 degrees. You cannot combine those. You have to leave them separate. And then for our final step for finding the value of x, we divide both sides by what's in that parenthesis. So now we have x equals 50 times the tangent of 22.2 divided by the tangent of 36.7 degrees minus the tangent of 22.2 degrees. And we are finally ready to reach for a calculator and figure out the value of x there. Now, depending on what type of calculator you're using, you have to be really careful with this. When you type a fraction in, if you're not using a TI-84, if you're using just a scientific calculator, you have to make sure that your parentheses go around your angles, and that when you divide by a binomial like we have here, you have to put extra parentheses around the entire denominator. And honestly, to be certain, you probably should put extra parentheses around the top. Now technically that's a monomial, so it would be okay in this case, but if there were any addition or subtraction up there, it would require the extras. So you can see the burden of typing this into a scientific calculator versus a TI-83 or 84. Okay, so we typed that in, and what I got was that x was 60.49675,201, and that is in feet. Okay, so that's my x. Unfortunately, I didn't ask you to find x. X is the distance from the tree to where Francisco stood this first time. I want you to find the height of the tree. To find that, we now have to substitute that value of x back into this bubble here. And that will tell us what h equals. So we know, finally, that h equals whatever x is times the tangent of 36.7 degrees. And if I just multiply that out, 60.49675,201 feet times the tangent of 36.7, that gives me an h value of about 45.1 something. Let's find that exactly. Okay, so what I actually got was 45.09288,923. But this problem only had, well, actually it really only had one significant digit from the beginning, but I gave it 2. But then at the end they tell you to round it to the nearest foot anyway, so you still would have ended up with 2 significant digits. So we will round that to 45 feet. So it looks like Francisco's tree is approximately 45 feet tall. And that wraps up section 2.5.